top of page 402, we have the last formula that's on our formula sheet, which is called the change of base of a logarithm. And we're going to learn where it comes from. So if you have any logarithm with base b of x, you can change it to any new logarithm by the following formula. Where this is really nice is this change of base theorem for most calculators that don't have the log base. Look what you can do. If you wanted to figure out what is log base 2 of 6, which was a question we had before, okay? My base is 2. Inside I have a 6. I can change it to, using this new formula, to log base anything of 6 divided by log base anything of 2. And I can put any new base in here that I want. Well, what's nice is your calculator has a log base 10. It has the natural log with the base e. So what you could do is you could choose to put 10 here. You wouldn't have to write it in, because if you left it blank, it would mean 10. And we can find out, so first of all, my calculator has log base, so I'm going to type log base 2 of 6, just so we have an answer. We know that it's equal to this. According to the change of base theorem, I could have written log 6 divided by log 2. I get the same answer. I could have also written natural log of 6 divided by natural log of 2. I get the same answer. You can change logarithms to any base that you want. So for example, if you had log base 3 of 7, you could change it to log 7 over log 3. Or log e of 7 over log e of 3, which is natural log of 7 over natural log of 3. And this allows you to use, instead of using the log base, the log button and the natural log button are on every scientific calculator. So now you can evaluate any logarithm quickly. So here I have one extra question that I'd like you to do, which says combine this as a single logarithm. You can just write this off to the side. And here we're going to use this last change of base theorem. I notice I have a log divided by a log, and both of these have the same base here, 10 and 10. So I can use my change of base theorem, and I can change this to log base 3 of 7. So I took the right-hand side of that formula, and I changed it to the left-hand side of that formula. What does that mean? That means now I can combine it to a single logarithm, log 3 of 35. And of course, if I wanted to quickly evaluate this on my calculator, I could use the change of base theorem again and type in log of 35 divided by log of 3. So let's look at example 1. And what they're really, it says approximate each value to the nearest thousandth. So this would be a calculator question. So what they're wanting you to do is use your change of base theorem so you could type it quickly into your calculator. And it's only been in the last 10 years or so that newer calculators have included the different bases for logarithms. So we type in log of 50 divided by log of 5. and get 2.43. Same thing here, we would type in log of 6 divided by log of 8. Oh, to the nearest thousand, sorry, 2.431. .862. What are we doing this way? We are actually solving the following. It says write the related exponential expression as an exponential expression in A. If we let x equal log 5 of 50, then you would have 5 to the x equals 50, and we now know that that exponent that makes that work is 2.431. In B, if we let x equal log 8 of 6, this means 8 to the x equals 6, and we now know that that x, in order to make that work, would be 0.862. Circle questions 3, 4, and 5.